I am Singh, Dhas, Research Scholar, Department of Computer Science, Jaya Arts and Science College, Karur, and my guide, Dr. B. Mukunthan. My title is Investigation of Different Clustering Techniques with the Temporal Relational Data Points. Abstract. The temporal data clustering is a major output to the different problems for discovering the essential configuration and packed information over chronological data. The set of sequential data were collected in a series of different time periods. The different data mining methods have been developed in the temporal relational data study, but the perfect study was not performed with the least amount of time. The best possible numbers of clusters are obtained and minimize the incorrect data clustering which improves the accurateness. Our main aim is to get better accuracy and reduce the computing time with the minimal memory space complexity during clustering process with the temporal relational data by using data mining techniques. Introduction. Bitemporal data study is a detailed case of time-based database information to hold the sequential data along with the two different timelines. Time series investigation is a statistical performance that defines the data in the series of exact time periods for tracking the performance of a specific occurrence. Clustering is an important data mining method that dividing the data points into different clusters. A variety of clustering algorithms has been developed for a long bitemporal dataset with various attribute calculations. Since the dimensionality of temporal data is significantly larger and more complex, the research work is focused to involve the significant data object clustering algorithm to overcome the computational problems. Next, temporal relational data on clustering. Data clustering is an exploratory and graphic data analysis method with the extended relation in selection of specific scientific fields. It is offered with the data instances that are grouped reliable with the similarity. Clustering is carried out with a early postulation on distance metric, data structure, number of clusters, data distribution, etc. When there is no correspondence between the assumptions and definite model of clusters, designed algorithm resulted in poor clusters. In this temporal relational data clustering, we followed three methods. First one is the density and frequency aware clustering algorithm. A new clustering method was designed and introduced for spatio-temporal progression data regarding the density and frequency. It splits the data elements into the high density high frequency dataset, high density low frequency dataset, and low density high frequency dataset. It groups every dataset individually by the clustering process. It is employed in a spatio-temporal frequency reachability to identify the clusters in low density and high density high frequency set. Find SP density frequency clusters were taken as input comprising set of spatio-temporal sequence data. Next, second method is parametric link among multinomial mixtures, that is PLMM. Parametric link among multinomial mixtures is a clustering model from a source to destination data having the parametric link between the distributions. The parameters of the multinomial distributions are to analyze the temporal data. The highlight of this model is to develop a novel evolutionary clustering method by exploiting the link parameters and provide interpretation of the link parameters to describe cluster evaluation. The next phase is the sequential approach. The active selection of clustering limitations was employed for minimizing the cost of acquiring constraints and comprises quantifying utility of the given constraint set. A sequential method was introduced to choose the beneficial set of limitations activity. An active constraint selection technique was introduced and ignored the constraint utility dependencies. The utility measure was updated after every constraint selection step to avoid choosing the redundant limitations. A criterion was employed to determine the efficiency of every constraint. Every constraint allocated individual utility without considering dependency among the constraints. Next, performance of temporal relational data clustering techniques. Various parameters are employed for improving the clustering performance of temporal relational data. In this paper, we have used three parameters. That is, first one is clustering accuracy, next one is computing time, third one is the memory space complexity. Regarding the first one, that is clustering accuracy, is defined as the ratio of number of temporal relational data that are correctly clustered to the total number of temporal relational data. This is the slide for the tabulation graph showing the clustering accuracy. Here the table shows the number of temporal relational data points. Next one is the density and frequency aware clustering algorithm. Next column, that is PLMM method, and the next column is the sequential method. We have developed, that is 10 data sets for the different clustering algorithms and different methods followed, and we got the result as shown in the table, and corresponding table is drawn by the graph using the same data. The graph is drawn, line graph is drawn and shown here. From the figure and table, the clustering accuracy for clustering based on different number of temporal relational data points consumes high accuracy in density and frequency aware clustering algorithm. Hence, 3% greater accuracy for clustering than PLMM method and 6% greater accuracy for clustering than sequential method. Next phase is the computing time analysis. The computing time for clustering is defined as the difference of the ending and starting time of the clustering, the temporal relational data. This is the tabulation. This is the slide shows the tabulation and the graph showing the computing time. Here also the same table format is followed, and the 10 data sets are shown for the analysis in the table, as well as a corresponding table is drawn by a graph, that is line graph, as shown in the slide. That is, the blue line shows the FAC, that is frequency aware clustering algorithm method, and the red line shows the PLMM method, and the gray line shows the sequential method. From the above figure and table, the computing time for clustering based on different number of temporal relational data points is described. The research in density and frequency aware clustering algorithm consumes 4% lesser computing time for clustering than PLMM method and 17% lesser computing time for clustering than when compared to sequential method. Next, the third phase work is the memory space complexity analysis. The memory space complexity is defined as the product of number of temporal relational data and memory space consumed of one temporal relational data. This slide shows the tabulation and graph showing the memory space complexity. Here, same table format is shown, and we have taken the 10 data sets for the analysis, and the 10 data sets are shown by a line graph. And here the blue line shows the FAC, that is frequency aware clustering algorithm, and the red line shows the PLMM method, and the gray line shows the sequential method. From the figure and table, the memory space complexity for clustering based on different number of temporal relational data points is described. Research in PLM method consumes 7% lesser memory space for clustering than sequential method and 28% lesser memory space for clustering than density and frequency aware clustering method. Next. Data collection. The dataset is collected from the UCI machine learning repository. Dataset collected from the following website. The dataset comprises the temporal data points from a wearable accelerometer fixed on the chest. Then the slide shows the future direction and conclusion. The future direction of clustering techniques for grouping the temporal relational data points can be carried out using machine learning techniques with a higher accuracy, minimal computing time, and memory space. From this study, it is clear that the existing clustering techniques consumes large amount of time for grouping the similar temporal relational data. This study process shows that the existing density and frequency aware clustering method to improve the clustering accuracy and computing time and performance. Sequential method failed to avoid temporal relational data to go beyond during the clustering process. The PLM method performed better in memory space complexity. Finally, from the research work can be carried out using machine learning for enhancing the clustering accuracy and minimizing the computing time and also the memory space complexity. Then these are some of the major references shown in this slide, and thank you.